hydronium ion concentration for any acid solution can be calculated by multiplying the percent reaction by the initial concentration. And so here's two situations, right? Strong acids, we assume that the concentration of ammonia ions is, and this is what you have to write down, that is equal to the initial concentration of the acid. So for these questions, if you're disassociating a strong acid, if the concentration initially was 2 moles per liter of sulfuric acid, the concentration of sulfuric acid would still be 2 moles per liter. For weak acids, we actually need to do a little bit of work where we have to calculate the hydronium ion in the solution because it doesn't disassociate completely and we have that equilibrium reaction. So, and the reason, right, only a small portion of the initial acid concentration is converted at equilibrium. So we have a formula that helps us figure out the percentage ionization. So the percent ionization is equal to the hydronium ion concentration divided by the initial concentration of the weak acid. That is what HA stands for. Questions that deal with this percent ionization, I mean, they're not seen a lot, but they are seen, so we'll kind of take a look at a few questions that deal with that. And these will be the concentrations, like, at equilibrium. We couldn't use this formula unless everything already had went to equilibrium. If there is an initial change and then the equilibrium concentration, we'd have to use the ice tables to figure out like my ionization constant. You should write down formula. There's not much space there. Did I change that? There was more space on this. There's no space. Sorry, I thought I had changed it. The bottom question, you don't need that much anymore.
So, like, if they are an aqueous, then this doesn't work.
Right, yeah. And we're dealing with acids, so we should always be aqueous. Yeah, so make sure you write down that formula. Everybody's got it. Okay. Oops. Oh, there's the answer. Looks like we need to find. Okay, so here's an example that deals with that formula. So a 1.0 mole per liter solution of acetic acid. Only out of that solution, only 1.3 of the acetic acid molecules, or the acetic acid molecules have reacted at equilibrium to form hydronium ions. Calculate the hydronium amount concentration. So what's happening here is that the acetate ions, right, like vinegar, if I react that with water, which is in liquid form, and this is aqueous, it's a weak acid, so I'd have those double equilibrium arrows, producing hydronium, which makes the acidic properties, as well as a acetate ion. CH3COO negative, because I removed one of these hydrogens, right? This guy's essentially getting removed. And this reaction is happening at like a 1% rate. This is at a less than 1%, 1.3% rate is what this reaction is happening at. They are asking me to figure out this guy's concentration. And so I can use the formula that we just had there, that the percent ionization is equal to the hydronium ion concentration over the initial concentration of the acid, and that's a percentage, so it's times by 100%. So then I just need to take the information from the question and put it into there. So I know I have a 0.1 mole per liter solution of acetic acid. That is the original ion concentration. I'm looking for the concentration of hydronium. And the percent ionization of this reaction is at a 1.3%. So then, mathematically, to get this to work, the first thing you should do is what?
Multiply. Oh, divide by.
Yeah, we want to get rid of that percentage first, right? Usually we would change this to a percent, or maybe not even write this down, right? And just write that down as a decimal. So divide by 100%, divide by 100%. So that gets rid of this here, and this becomes 0.013 equals the hydronium ion concentration over 0.1, and then I just need to cross multiply and divide by 1, which does nothing. So the hydronium ion concentration is equal to 0.000, so 1.6 is 2, 3 times 10 to the negative 3 moles per liter. Oh, his microphone's way over here. You probably didn't hear me. Oh, well. He's probably not going to listen to it anyways. Just kidding. Maybe you did. If you tell me the word zebra, I'll give you a bonus mark on your test. Tomorrow, you have to tell me the word zebra tomorrow, May 10th. Nobody tell him. So you can actually listen to this. We all know he's... Okay, so the pH of... another question here. The pH of a 0.1 mole per liter of methanoic acid solution is 2.8. Calculate the percent reaction for the ionization. So they are asking me what is the percent ionization. So you need to figure out the hydronium ion concentration as well as the original concentration of the acid and times that by 100%. I do have the original concentration of the HA, which is 0.10 moles per liter. How do I figure out the hydronium ion concentration? Pardon? Right, I use the pH, and so we use our formulas from Chem 20. To figure out the hydronium ion concentration, it's 10 to the negative pH. So 10 to the negative 2.38, and which gives me 4.2 times 10 to the negative 3 moles per liter. And that goes here then. So 4.2 times 10 to the negative 3. Why don't I need to like times by something, divide by something? You know, like in a... Yeah, most acids, pretty much all acids with the exception of sulfuric acid is going to be that 1-to-1 ratio, so we don't need to worry about that. While the bases, you know, if you have calcium or barium, they have that ion of 2, which creates 2 hydroxides, so you have to be careful for that. And then I need to times this by 100%. And so my percent ionization is 4.2%. So I can either report it like that, or they're saying that, what is it, methanoic acid, CHOOH plus water is producing at a 4.2%, less than 4.2% would be producing water, and hydronium, what the heck am I doing? I do want to just move on briefly to talk about acid-base theories, and then we'll kind of go into the new theory that we're looking at tomorrow. So none of this is just, you don't have to write down any of this, this is just to remember from Chem 20, and then we're going to build on that for the theory that we look at tomorrow. So you would have looked at the Arrhenius theory for an acid and a base last year. There's something to write down right now. This is just talking about what we looked at last year. So he looks at a theory that explains a little bit of acids and bases. So here's the basis of his theory. So according to Arrhenius's, bases are ionic hydroxides that dissociate to form hydroxides in water. So according to him, if something is if something is a base, it actually has to have NaOH in it, right? The problem with this definition is it doesn't work for like ammonia, which is basic, right? In a lot of house cleaners, it doesn't account for why this is basic. But this is still his proposition as to why things are basic, is they have this hydroxide ion in them. Acidic compounds, he realizes that they need to ionize, like react with water, but he still says that they have to have some sort of hydrogen in them in order to create acidic properties, which doesn't account for some of the acids as well. So then you should have looked at the modified Arrhenius theory, and this is the kind of the theory we still use in part here, and then we add to it, but this is what you would look at last year, is that for an acid, acids are a substance that react with water, and the water ends up gaining the hydrogen. Right, the hydrogen transfers over to the water to create my hydronium ion. Hydronium ions are what's responsible for acidic properties. And then I have my corresponding anion there. If something is basic, I either have ionic hydroxides, which are strong bases, or we can have other weak bases that react with water to produce hydroxide. So what's happening here then is the hydrogen would add on to ammonia. I end up with hydroxide and get the ammonium ion. So there's still some problems with this, so we do end up having a new theory that we're going to look at, and there's more theories than just these three, but this is the one that you use for high school, is the Bronsted-Lowry acid, and so we'll look at some more information about how this theory works tomorrow. We'll just leave it at that for now. So you're going to do homework 5. Homework 5, questions 1 to 4. So homework 5, numbers 1. I added 2 there at the end and I don't like them, so. I don't usually when you like hold the wrist, it for sure goes in, right?